in this example, we'll see a different strategy at play. So if you recall, we saw earlier that the sine squared x can be written as 1/2 1 minus cosine of 2x. We'll see that using this identity is going to be helpful in evaluating the integral of sine squared. Okay? Because by applying this identity, we're essentially removing the power from the trig function. So let's see, if I rewrite sine squared as 1/2 1 minus cosine of 2x, then actually this is already in a form that we can integrate. So the integral would be 1/2. Integral of 1 is x minus integral of cosine 2x will be sine 2x over 2. In this case, then we're going to evaluate from 0 to pi. And let's see, so when we evaluate it at pi, we get pi minus sine of 2 pi over 2, minus, when we evaluate it at 0, we'll just get 0, right? And let's see, when we evaluate sine of 2 pi is 0, so we're just left with 1/2 times pi, or pi over 2. Okay, so we see that when we see just sine squared in the integral, this identity will be very useful. Or if we see cosine squared, the other one will also be a handy one. Here we got sine to the 4th, and in this case we'll extend on the strategy that we did in the previous example, because here sine to the 4th can be written as sine squared squared. So inputting our power reducing identity for sine squared, this integral will become 1/2 1 minus cosine 2x squared. And then I can square this out. So 1/2 squared becomes 1/4. And then 1 minus cosine 2x, I'll FOIL that out, will become 1 minus 2 cosine 2x plus cosine squared 2x. Okay. Now we see it's not quite done because we still have a cosine squared in the integral. So we can use the cosine squared formula. It says cosine squared is 1/2 1 plus cosine 2x. To rewrite this part here, and that will completely remove all of the powers from our integral. However, in this case, notice it's cosine squared of 2x. So if I have cosine squared of 2x here instead of x, then I'll have 2x in for x here. So when I apply the formula, it'll be 2 times 2x, so it'll be 4x. Okay, so let's see what we have now. We'll have 1/4 1 minus 2 cosine 2x, that stays. And now we'll input this formula here. So plus 1/2 1 plus cosine of 4x. Okay. Now, actually, before I integrate, one last thing I would want to do is maybe combine some like terms. For instance, here I have 1, and then plus this other constant term, 1/2. So when I combine those together, 1 plus 1/2, after I distribute the 1/2 here, would be 3/2. This is just making it easier for the next step, which is to do the integral, making the integrand simpler to help with the integration. Okay, so now we're ready to integrate. So I'll have 3 over 2x minus the integral of cosine 2x will be sine 2x over 2. And then here I'll have cosine 4x, the integral will be sine 4x. So I'll have 1/2 sine of 4x over 4. Okay. And one last thing here to maybe clean it up a little bit more, I'll distribute the 1/4. So we'll have 3 over 8x minus here the 2's divide. So I'm left with 1/4 sine 2x. And then here I've got 1 over 4 times 1 over 8. So 1 over 32 sine of 4x. Okay. So you see, in this case, because we had an even power of sine, we were able to apply that power reducing formula, in this case multiple times, to remove all the powers from the integral, and hence get it into a form that we can integrate. So here's just a big overview of the strategies that we've seen. For the first few, we noticed that if we have a power of cosine that's odd, then we wanted to save one factor of cosine and use cosine squared equals 1 minus sine squared to express the remaining factors in terms of sine. And then we were able to substitute u equals sine x. And notice that the same strategy works if we have an odd power of sine. So we save one factor of sine, and then use sine squared x equals 1 minus cosine squared to express the remaining factors in terms of cosine, and then substitute u equals cosine x, and then we were able to integrate after the substitution. So notice that, yeah, if both sine and cosine have odd powers, then either strategy would work. In the case that sine and cosine both have even powers, then we wanted to use these power reducing identities. Sine squared is 1/2 1 minus cosine 2x, or cosine squared is 1/2 1 plus cosine 2x. And then we were able to completely remove the powers from the integral. Now we haven't seen an example that uses this identity yet, but that's our double angle formula for sine. We may see an example in the homework or in another example where we can use this formula.